All right, now we're going to discuss 11.5 and some more angle relationships in circles. So here we have a tangent BC to that circle, and then we have the secant that goes through the circle. So when we have this kind of setup, this angle, let me change this to green, this angle will be half of the arc. So again, it's the same thing, it just looks a little different. Angle equals half of the arc. All right, so how would these work? Well, I'm looking for the angle EFH. So EFH, angle equals half of the arc. So I'm looking for angle EFH. So let me use my green. That's where my X would go. X equals 1/2 of the arc. The arc is 130 degrees. So half of 130 degrees I'm typing this in. Parenthesis 130. Come on now. 65. So the measure of angle EFH would be 65 degrees. I can also use this formula to find what an arc would be. So if I want the arc GF, all right, GF is here. So let me erase this over here and get it out of the way. So I don't want your attention drawn to that. So EF is there, and here's a point, and then down here's the point. All right, here's where my connection is, and then here's where my connection is. So 122 degrees is on this side. Now this one's a little bit tricky. This one kind of jumped into a really hard one really fast. If this is 122 degrees, what is this angle? Do we remember how to find that? We're on a straight line. We haven't done a problem like this in a while, but a straight line would add to 180 degrees if you add these two angles together. So you would do 180 minus 122. 180 minus 122 is 58. So this angle would be 58 degrees. All right. So now we're going to go back to our formula. I forgot to put 58 there. The angle equals half of the arc. The arc is what I'm looking for, and that's where I would put an X. The angle is 58 degrees. So now I'm going to go back to Desmos, and I'm going to go up here, and I'm going to switch this to 58, and I'm going to switch this to X. So X equals 116 degrees. All right, same kind of thing. Picture just looks a little different. Okay, now we're going to switch gears a little bit. And whoa, what the heck is going on here, Miss Bearden? Well, measure of angle 1. So before we worked problems where the angle was on the circle, like an inscribed angle, or we had an angle on the circle with a tangent line. These angles are actually inside the circle, and P, this is super important, P is not the center. It's just somewhere inside the circle. If P were the circle, like if P were the center of the circle, then we know that this formula would not work. But these are just points inside the circle somewhere. And what you would do, so for angle 1, first of all, both of these angles right here are congruent. They're vertical angles, and vertical angles are congruent. It's been a little while since we've talked about vertical angles, but that's something that you can't forget because it's just that important. So both of those angles would be congruent, which means if we look at these multicolored arcs, we would average those, and that would give us the angle. So half of those two arcs added together will give us those angles right there in the middle when we're talking about angle 1. For angle 2, we would take half of the stars. So we would take half of AD plus BC. So we're going to add those two arcs together, and then we're going to take half. So here's just the way it looks like in the book with the big fancy words that you guys love to read. So let's see how we're going to find this problem. AEB. AEB. So it's this angle for sure. So the angle equals half of the arc plus the arc. All right, I'm trying to use what we're adding instead of giving you some sort of variables that are going to change. So my angle is x, that's what I don't know. X is half of the arcs. One's 139, the other one is 113. It doesn't matter which one you write first, because when we're adding, we're going to get the same thing. So x equals half 139 plus 113. So x would be 126 degrees. All right, a couple more examples of those. All right, now I'm looking for ABD. ABD, so arc equals, it's not arc, that should be angle equals half of the arc plus the arc. So the angle is x because that's what I'm looking for. I don't know it. Then I got 65 and 37. So over here, this would change to 65. This will change to 37. So x is going to be 51 degrees. All right, this is pretty straightforward stuff. You use your formula, you type it into Desmos, you get your answer. Now, I'm going to find the measure of R in M. R in M. All right, this one's a little different. R in M. So this is what I need. Okay, this one right here. So I'm going to be using this arc and this arc. But I don't have any numbers there. How do I figure it out? Well, that's a really good question. How many degrees are in a circle? Yeah, 360 degrees total. All right. So obviously MR and QP are going to be different sizes, but let's figure out what I got left in this circle. So 360, subtract 91, subtract 225 is 44 degrees left. That means that MR, all right, that MR and the QP have 44 degrees to share between the two. Does it really matter if I know how big MR is or how big QP is? Does that really matter? Because in my formula, I'm just going to end up taking half of whatever it is when I add those two together. So it doesn't really matter if I don't know what they are as individual pieces. What's important is I know how much they equal together, because that's what I need half of. So 44, this is what it's going to end up looking like. X equals half of 44. All right, I can do that one in my head. It's going to be 22 degrees. So that problem is just a little bit different. You got to do some other subtracting to figure out how to do that one. All right, we got a couple more things to go through. I know this has ended up being a long video, but we're almost at the end of the tunnel here. All right, so these kind of look like our ice cream cone theorems. They're not, this one is really the only one that's the ice cream cone. The other two are just, well, what if we've got an angle that's outside the circle? All right, notice again, I got 1/2 of something. So the angle is going to be half, but this time, what am I doing? I'm not adding, I'm subtracting. Before, it didn't matter which order that you added, but when you subtract, it always makes a difference. And if you look, this should say arcs instead of angles. I don't know what was going on with that. All right, so if you look, this X one that I have labeled X is always the bigger. So the angle, let's change back to some blue here. The angle will always equal half of the big arc subtract the small arc. Okay? So big arc subtract the smaller arc. And you can just look at those and visually see which one is bigger than the other one. So here's how we do these problems. For example 8, I want to find the value of X. So X is an angle outside the circle. So X is the angle outside the circle. So here's the formula I want you to look at. Angle equals half of the big arc minus the small arc. So when I look here, I need a half. The bigger arc is right here. It's 7, and that one, the big one is 87, and the small one is 7. So 1/2 of 87 subtract 7. So 1/2, we're going to alter this just a little bit. We're going to say 87 subtract 7. So X is 40. All right, big subtract small. Over here, it's outside. I got to subtract. This is the big one. It's 200 minus 74. So when I type it in, 200 minus 74. That's going to be 63 degrees. All right. Fairly easy. I know it's a lot of different formulas, but in every one of these formulas, we're taking half of something. All right, for most of the problems, it's half of the arc. But when you got a different kind of scenario, maybe you got to add the arcs, maybe you got to subtract them. All right, that's the hard part that you've got to remember. Okay, so this one's a little bit different scenario. I'm going to use the same formula. The angle on the outside equals half of the big subtract the small. All right. What's my angle on the outside? 25. So 25 equals 1/2. What's the big arc? All right, here's my arcs. I got this one here, and I got this one. Obviously, the 83 is bigger. Visually, I should be able to understand and see that 83 is bigger. So 83 subtract x. And now, Desi's my best friend. She's going to figure this out for me. I just got to change some numbers around. And then let me double check that I typed it in correctly. 25 equals 1/2. 83 minus x. 33. X equals 33. All right, to sum this up. If you're touching the circle, it's half of the angle. All right, so angle equals half of the arc. If you're inside, it's angle equals half. I'm running out of room here. Angle equals half of arc plus arc. And if you're on the outside, all right, angle equals half of big subtract small. Arcs, okay? Now we need some practice.